Classify black and white photos of clothing. The Fashion-MNIST clothing classification problem is a new standard dataset used in computer vision and deep learning. Although the dataset is relatively simple, it can be used as the basis for learning and practicing how to develop, evaluate, and use deep convolutional neural networks for image classification from scratch. This includes how to develop a robust test harness for estimating the performance of the model, how to explore improvements to the model, and how to save the model and later load it to make predictions on new data. Fashion-MNIST clothing dataset classification. The Fashion-MNIST dataset is proposed as a more challenging replacement dataset for the NIST dataset. It is a dataset comprised of 60,000 small square 28 x 28 pixel grayscale images of items of 10 types of clothing, such as shoes, t-shirts, dresses, and more. The mapping of all 0 to 9 integers to class labels is listed below. 0. T-shirt/top. 1. Trouser. 2. Pullover. 3. Dress. 4. Coat. 5. Sandal. 6. Shirt. 7. Sneaker. 8. Bag. 9. Ankle boot. Importing the required libraries. In 37, from Tensorflow.Keras.Models. Import sequential from Tensorflow.Keras.Layers. Import conv2d from Tensorflow.Keras.Layers. Import max pooling 2d from Tensorflow.Keras.Layers. Import flatten from Tensorflow.Keras.Layers. Import dense from Tensorflow.Keras.Datasets. Import Fashion-MNIST from Tensorflow.Keras.Utils. Import to_categorical from Tensorflow.Keras.Optimizers. Import SGD from Tensorflow.Keras.Models. Import load_model. Import numpy as np. Import matplotlib.pyplot. As PLT load train and test dataset. In 38, def load_dataset, x_train, y_train, x_test, y_test, equals fashion_nist.load_data. Hashtag reshape the dataset to have single channel x_train equals x_train.reshape, x_train.shape 0, 28, 1, x_test equals x_test.reshape, x_test.shape 0, 28, 1. Hashtag 1 hot encode target value y_train equals to categorical, y_train, y_test equals to categorical, y_test. Return x_train, y_train, x_test, y_test shows some train images of clothes. In 39, classes equals t-shirt, trouser, pullover, dress, coat, sandal, shirt, sx_train, y_train, underscore equals load_dataset, fig equals plt.figure, fig size equals 20, 4, for idx in range, 20 plt.subplot, 2, 10, idx plus 1, sticks equals, itix equals. plt.imshow, x_train idx.reshape, 28, map equals gray, plt.title, classes y_train idx.argmax. Scale pixels. In 40, def prep_pixels, x_train, x_test hashtag convert from integers to floats x_train_norm equals x_train.astype, float 32. x_test_norm equals x_test.astype, float 32. Hashtag normalized to range 0 to 1 x_train_norm equals x_train_norm / 255 x_test_norm equals x_test_norm / 255 hashtag return normalized images return x_train_norm x_test_norm define CNN model. In 41, define _model, model equals sequential, model.add, conv2d, filters, equals 32, kernel_size equals 3, kernel_initializer equals he_uni model.add, max pooling 2d, pool_size, equals 2, model.add, flatten, model.add, dense, units, equals 100, activation equals reload, kernel_initializer equals he_unifor model.add, dense, units, equals 10, activation equals softmax, hashtag compile model opt equals sgd. Learning_rate equals 0.01, momentum equals 0.9, model.compile, optimizer, equals opt, loss equals categorical_cross entropy, metrics equals ACC return model run the test harness for evaluating a model. In 42, def run_test_harness, hashtag load the dataset x_train, y_train, x_test, y_test equals load_dataset, hashtag prepare pixel data x_train, x_test equals prep_pixels, x_train, x_test, hashtag define model equals define_model. Hashtag fit the model on training images model.fit, x_train y_train, batch_size equals 32, epochs equals 10. Hashtag save the trained model for future use or deployment model.save, /content/drive/my drive/deep. Learning and computer vision /saved_models. Entry point, run the test harness. In A, run_test_harness. We can now load the final model and evaluate it on the test dataset. In 55, hashtag load the trained model. Model equals load_model. /content/drive/my drive/deep learning and computer vision /saved_. Hashtag load the test data x_test, y_test equals load_dataset. Hashtag prepare pixel data x_test equals prep_pixels, x_train, x_test. Hashtag evaluate the model loss, accuracy equals model.evaluate, x_test. Y_test. Print, accuracy of the model on the test dataset, round, accuracy, 4. Print, loss of the model on the test dataset, round, loss, 4. Accuracy of the model on the test dataset, 0.9009 loss of the model on the test dataset, 0.3121. Make a single prediction. In 64, from tensorflow.keras.preprocessing.image. Import load_img from tensorflow.keras.preprocessing.image. Import img_to_array from tensorflow.keras.models. Import load_model. Hashtag load the single image img equals load_img. /content/drive/my drive/deep learning and computer vision/images/clo. Hashtag covered image into array img equals img_to_array img. Hashtag reshape image into 1, 28, 28, 1. img equals img.reshape 128, 28, 1. Hashtag prepare pixel data img equals img.astype float 32. img equals img/255.0. Hashtag load the saved model equals load_model /content/drive/my drive/deep learning and computer vision/saved_. Hashtag predict the class pred_class equals model.predict img. Hashtag show predicted class print pred_class.argmax plt.imshow img.reshape 2828 map equals gray plt.title classes pred_class.argmax. Out to text 0.5 1.0 pullover in colon.